Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2016 Division AA Algebra 2, which I'll be answering questions 19 and question 20. So, question 19. Bob's boat travels at a constant speed in still water. The current in the river has a constant speed also. Bob makes a round trip driving the boat upstream from the ramp to his cabin and then returning to the ramp. The average speed of this trip is 36% of his still water speed. The speed of the current is k% of his still water speed. Okay, so let's first find the average speed first because that's the information they want us to know. So let's say x is our distance. So x go up, x go down. So upstream, down the stream. So that's a total distance of 2x. So now what is the time that goes up the stream? So the time it goes up the stream is the distance divided by the speed. So the speed when you're going up, that means basically the water is working against you. So Bob's speed minus the water speed. Now what's the time that you go down the stream? Well, it's the distance divided by the speed going down. So now the water is working with you, so it would be B plus W. And that overall speed is equal to 36% of its still water speed. So it's over to 0.36 of B. Okay, so I know we could cancel out the x's because you're just x divided by the x. So now we just have 2 divided by B plus B is 2B, negative B minus plus W is 0, so it's just 2B on top, divided by B minus W and B plus W. That's equal to 0.36b. So cancel out the 2's, so then b squared, and then minus w squared. That's the thing on the bottom. So your dividing is the same thing as multiplying by its reciprocal. So now the b is on the bottom and is equal to 0.36b. So that is b squared minus w squared is equal to 0.36b squared. So move the b squared to one side, so that's 0.64b squared is equal to w squared. Now square root both sides, so you get 0.8b is equal to w. And then in the question, we simplified. So the question what they're asking, the speed of the current, which is w, is k% of the still water speed. So w to b, that's basically what they're asking for. So w is 80% of its still water speed. So the value for k is 80. And that's all you have to do for number 19. You just manipulate your variables around. Number 20. So, a group of two n mathematicians consisting of exactly n men and exactly n women are having a dinner meeting. One of the mathematicians, Cindy, notes that there are k distinct arrangements possible if they were to sit at a round table and that men and women must alternate. Another mathematician, Tom, suggests that the group find the minimum value for n such that there will be more than 100k, 100,000k distinct arrangements if they were to sit at a round table and men and women didn't alternate. Determine that determine that minimum value of n. Okay, so we need to find two things. We need to find the number of arrangements when they alternate and the number of arrangement when they don't alternate. So let's start with the easiest one. Find the arrangement when they don't alternate. So we have a table and we have two n people. I'm just gonna draw an even number of people. Let's just say 4. Right, so we have 4 people. They don't have to alternate. So they're equal amount of men and women because n women and n men. Right? So let's say man, woman, and then woman, man. So it doesn't alternate, right? So how many ways can you arrange this? Well, if you kind of think about it, if we're thinking about combinations, we always think about factorials. So if we have, let's say 4 people, right? We call it A, B, C, D. How many ways can we arrange for A, B, C, D? Well, the basic idea is just 4 factorial, right? So if we kind of think instead of 4 and now we have 2n, now we have 2n factorial. So that's a logical way to think about it. So there's 2n factorial ways to when there's no arrangement. But that's only if that's on a straight line. So this idea is if it's like A, B, C, D, and then like A, D, B, C or something like that. But let's say we have something like A, B, C, D, C, D versus D, A, B, C, right? Well, this is exactly the same thing as ABCD. And the reason is because if you put ABCD around a circle, A, B, C, D, and then you put DACB, so D, A, B, C, right? All you had to do is just rotate it 1/4 and sorry, oops, I did it in the wrong direction. Rotate it this way, right? Then your A is gonna go to your D, so A is gonna go here, and then C goes down, D goes to your left, and B goes to your right. So it's exactly the same thing if you rotate the circle around. So to do that, all we had to do to take away this combination is actually just subtract 1. And the reason is because if you kind of take 2n factorial, what you do when you kind of subtract 1 is that you take away one of the combinations, which is basically A, B, C, D, and then D, A, B, C. Because the first combination and the last combination are exactly the same thing. Because basically all you do is just inverted it. So you just need to take away that 1. So now how many ways can you like this is the number of ways that it doesn't alternate. So how many ways can we do it where they must alternate? So now it's like men, women. So now this one's man. And then the other one on the left is now women. So now how they alternate? Well, now, well, to do this is basically the same idea as 2n minus 1. So we have to take away 1 later on from one of the men or women, doesn't matter which one, because we just need to take away the first seat. So we're looking at this, right? All we have to think about is how many ways can we arrange the men and how many ways can we arrange the women? Well, that's easy, right? The amount of ways you can arrange the men is n factorial because there's n men. Now, how many ways can you arrange the women? Well, it's just n factorial. That's the number of ways you will arrange the women. And as I said before, you can subtract 1 when you're in a circle. So subtract 1 from the men and women. Well, I start with the men, so let's just subtract 1 from the men. Because it doesn't really matter, because if you rotate around, it's the same case. So it's n minus 1 factorial and n factorial. So those are our two combinations. So let's delete this because we don't need it anymore. I'll just rewrite it. Okay, so basically what it tells us is that n minus 1, which is the one, n minus 1 factorial, n factorial times n factorial is equal to our k, because that's the number of ways you can arrange in a circle in a round table where they must alternate. And then 2n minus 1 factorial is the amount of ways you can arrange around a circle, and it must be greater than 100,000 k. Okay, so we need to find the minimum value of n that this happens. So basically all you have to do is just look at the inequality, and then we have 2 minus 1 factorial minus 100,000 times k, which is just n minus 1 factorial times n factorial. And then that is greater than 0 now, because we subtract 100k from both sides. Well, 100,000k from both sides. So basically all you have to do is just put it in your calculator and find the first value of n such that this side is positive, right? So the first value when you plug it into your calculator is when n is equal to 11. And that's basically all you have to do. You basically just need to find those two ways to arrange the general formula and then just plug into your calculator. Well, thanks for watching, and I'll see you at the next math record.